Now we come to the discussion of vector and kinematics. So first we'll do a theoretical discussion and then we go on to problem. Now the theory, basically, you see, you have to pinpoint some areas. For vector, it is the first the triangle law that you have to take care of, and then we have to do the parallelogram law, that is the vector addition. So in this addition is what we have to understand, that addition includes everything. So that is the triangle law, then that is the parallelogram law. Everything is involved in case of an addition. So this, by addition, we mean have a very broad perspective. In fact, subtraction of vector is also is addition in a different way. So when you are saying we are adding vectors a and b, we put it like this, and when we say we are subtracting two vectors, actually we are, this a minus b is basically a plus of minus of b. So we are reversing the vector and adding. So that has to be taken care of. When you are basically subtracting, you are adding in vector. Now the multiplication part of vector is very important as far as the dot product is involved. The dot product gives the projection. The application of dot product gives us the projection of vector, and along with the projection, the second part is the angle between the two vectors. So when we go on to solving problems, we'll find that how these values are actually applied for a particular problem. But here we are discussing only the key areas where we'll focus. Now the dot product has an importance, obviously, but the cross is even more important as it is associated with the direction. And as you know, if there are two vectors a and b, then the cross product goes like this, which is a cross b. Now if you multiply where this is the angle between the vectors a and b, now if you multiply b cross a, then that goes in this way, b cross a. So b cross a is actually the minus of a cross b. So this is very important when applying, because there are many questions have come previously that a cross b is c, b cross a is d. What is the angle between c and d? So you can say that the angle here is pi or 180 degree. So this kind of observations are very important when you go to vector. And along with that, the commutative law of vector addition is very important again, when we say that the two vectors, if a dot b, that is equal to b dot a. So this particular rule we will apply in solving problems, and will show you that how they are applied in a particular problem. Now regarding kinematics, we have some zones which are very important. Now the first part, that is what we have, the position on distance and displacement. There are a lot of problems based on this two things, distance and displacement, where we need to apply the concept of distance and displacement, and we'll have solving problems on distance and displacement. The second is a kinematical equation. So kinematical equations are equally important, and we have to take care of problems on kinematical equations. Now kinematical equations along with vertical motion, that is what is very important. While solving problems, we'll show you what are the nitty-gritties of vertical motion. And finally we've come to projectile, which is again a very important part. Now projectile, as far as NEET is concerned, we have projectile only on a surface, where you should know that, and I hope you know that at every point the component of horizontal component of velocity, that is u cos theta, remains the same. Many problems had been framed on this concept itself, that every point your u cos theta remains the same. So that is a point where you have to be very careful about. Now there are some one or more things regarding relative velocity. Now relative velocity, the particular case of relative velocity deals with the situation of crossing over of rivers, and Rainman situation. So while we go to problem solving session, we will deal with both of them. We'll deal with both of them and show you that how in case of a river crossing and how in case of Rainman you should approach a particular problem. Now the theoretical inputs that you have with you are very important, obviously. but NEET is all about application, you see, and rarely you find a theoretical question there, hardly 2 or 3 theoretical questions. Mostly there are problems which are mathematical and which we have to solve. You have to write something, you have to scratch something. So that is what we are going to point out here, that how you can solve those problems. And now we start the solving process. So the next we take up the problems and let us see how we can solve them. So let us solve some problems on vector which are very important for your forthcoming NEET exams, and we'll deal the theory as well. Now here we are finding that there are two vectors at an angle of 60 degree, the magnitude and the magnitude of the sum of the vectors and difference. Now this quantity, what you call sum, addition, everything means the result of what we call the parallelogram law. So when we are having a sum of vectors a and b, say we are getting the sum of vectors a and b, we should put it as root over of a square plus b square plus 2ab cos theta. When these two vectors, mind you, a and b are co-initial. Now that is a very important concept, that these two vectors should be co-initial and the angle between the vectors is what we call theta. And then what we can go on to write, putting the values of 5 and all that, this 5 square plus 5 square plus 2 into 5 into 5 into cos 60, and if we go on to calculate, then we get this as 5 root 3. So here we have an additional information for you. If there are two equal vectors and they are inclined at 60 degree, then the result is root 3 times the vector. If they are at 90 degree, the result will be root 2 times the vector. If they are at 120 degree, then the result will be 1 into the vector, they will remain same. If they are at 180 degree, then it will be 0, and if they are at 0 degree, then it will be 2 into the magnitude of the vectors. So this is a kind of an alternative which you should remember as a tip for solving problems faster. Now when you have the sum, you have it 5 root 3, so we can directly calculate as 5 root 3. And now when you are talking about difference, mind you, many have a misconcept about this concept of difference between two vectors. So here we have a and here we have b. These were two vectors which were related at an angle of theta. Now when we are asking you to find a minus b, that means basically we are adding a with b, but in this time the direction of b is reversed. So what we do is we reverse the direction of b and we get then the angle between the two vectors now as 180 minus theta, right? So we go on to solve the problem, this time with a value of a minus b, that is having a magnitude of root over of a square plus b square plus 2ab cos 180 minus theta, which is minus cos theta. So that result gives us, that is square plus b square minus 2ab cos theta. So if you substitute the values, you can find that 180 minus 60 is 120. So I hope you can get it mentally now, that if it is 120, then the resultant is 1 into the magnitude, so it should be 5 itself. Or you can just substitute the values 5, 5, 5, 5 and cos 120 to get the same answer as 5. So that is a very primary discussion on the angle between two vectors. And now we go on to the next portion, the next type we have, almost a similar one. If now here again a sum of two unit vectors this time is again a unit vector, then what is the magnitude of the difference? Well, we just had a discussion regarding this subject, that if the vectors are same in magnitude and then that the resultant is also equal to the magnitude, then the vectors should be at, I hope all of you remember, 120 degree. I hope all of you remember that we have from it in the previous page. This aspect we are applying here. If the two vectors are equal and the resultant is also going to be the same, so that is what we are applying here again. So the very simple part of the first portion of this problem is that we get the angle as 120 degree, and now we want to get to the next portion of the problem, is that when you are asking about the difference, we have just discussed that when we are asking about the difference, we are asking about the value of this, that is root over 1 square. Now why 1? Because there are two unit vectors. So 1 square plus 1 square minus 2 cos 120. So that will give you a value of, now this is, mind you, the resultant squared. So this will give you the value of root over of 2 and then minus 2 into minus half. So that will give you 2 plus 1. So that is root over of 3. So I hope those who are intelligent enough can calculate this value also mentally, as 180 minus 120 is cos 60 degree, and then when you have two vectors at 60, then we have the resultant as root 3 times. So you see, this kind of methodology you have to use and try to solve this kind of problems, which have come many times in competitive exams, various types of competitive exam, including NEET. Now we have a situation here where a body is moving, and as you can read from the problem, it is moving in a uniform speed in an anti-clockwise direction starting from A. Now starting from A means it moves, let us say that there is a figure where we are shown that it is starting from A. So here it is at A, then it is again here at B, then it is again here at C, and then it is again here at D. So we know this, that these are the direction of the velocities. Now first we have to calculate that what is the change in velocity in half a revolution. So you see, half a revolution means when the particle has traveled all the way from A to C. Now that change, if we calculate that change, then we can say that the change, if this is V and this is also V, then the change should be V minus of minus V. Now why this second minus? Because if this is V plus, then it should be V minus, and we are calculating the difference. Change means the difference, so difference of initial and final, so that gives you 2V clearly. Now you know any vector that is associated with a sense of direction. So if you put a sense of direction here, then if this is our east and then this is west, this is north and this is south, so the resultant will be directed, this resultant will be directed along south. So we have to also remember that this is the magnitude of the direction of change and the direction of due south. So the change is due south, having a magnitude of 2V. Now when you are taking the first quarter, you see the first quarter is this is the first quarter, 90. So you have a situation where the two vectors, these two vectors like this, and then there is again like this, these two vectors, you see we are at 90 degree. We have just discussed that if two vectors are at 90 degree, then their resultant or the change is given by root 2 times of V, and that can be calculated simply applying Pythagoras. So that is root 2V square, and then that is root 2V. So now if this is root 2V, then you can easily find out that this, let us draw the parallelogram, and if I find this resultant, which is a change as well, del V, then this angle it makes is obviously 45, as this is also V and this is also V. So tan theta is 45 degree, and as you can see the direction is this, so it is northwest. So the direction is northwest. Mind you, only when the angle is 45 you can call it northwest. Say here we have a situation like this, northwest, we have angle of 30 here. So this is not northwest, this should be taken as north of west, and say this is 60, then we should call it as west of north. So mind you, only when the angle is 45 you can call it northwest. Now we go on to the next one. Now here we come to a very important concept of vector, which we call the concept of resolution. Now resolution means breaking up a vector into two components, and that the basic concept behind this resolution we can take up like this, that if this is a vector and we have to resolute in two right angle components. So let us take this angle as theta. Then if we draw a right angle triangle, and if we have the value of the vector here, say for example this is vector f, whatever you may name it, you can name it a, you can name it b, you can name it r, you can name it f, whatever you like it, and say we are asked to find that the value of the base in terms of this hypotenuse. So the base in terms of the hypotenuse will be f cos theta. So that is the horizontal component of this f force. Now you are asked to find this component, so that is f sin theta. So that is what you call the other component, that is the vertical component, f sin theta. So the basic that you have to understand is this breaking up of component into right angle is fundamentally involving your basic Pythagoras triangle, and then we can remember that along the angle component is always cos theta. So you see, if I take this as tension T, then this will be T cos theta and this will be T sin theta. Now if I call this TB, then I can say that TB, that is the tension induced in the string OB, which I am asked to calculate, is very clearly T sin 30, because the angle involved here is 30 degree. And from another equation that I can have along the vertical plane, you can see that is T cos 30, that is equal to 4g. Now this is the weight, 4 into g, this is m into g basically, so it is 4 into 10, that is 40. So T happens to become 40 divided by cos 30, so that is 40 root 3 into 2, so that is 80 by root 3. Now if I am to calculate TB, then T I have already calculated, that is 80 by root 3 into sin 30, you know, is a half, so it is 40 divided by root 3. So you can see that the third option is correct here, 40 divided by root 3. So that is the tension in the string which is being pulled with. So now we go on to the next problem here, which deals with actually three directions separately, the x, y and z, and that we know the corresponding angles that we relate here is alpha, beta and gamma. So here you see we have that along the eastern line, so the eastern line clearly shows this is eastern line, so the angle alpha is 60 here as it is given in the problem, and the angle gamma, so because with the vertical it is again 60 degrees, so the angle gamma is given as 60. Now what we need to find out is the value of beta. So value of beta, if we calculate in that way, then we can apply the formula that the sum of square of the direction cosines should be equal to 1. So if we apply that, we have cos square alpha is 1 by 4, cos square beta we have to find, and cos square gamma is again 1 by 4, because you see cos 60 is half, so we are getting the square of it, and from there we can find that cos beta comes to 1 by root 2. So once you have these values, we can say that the rectangular form V is basically V cos alpha I, V plus V cos beta j, and plus V cos gamma k. So we have V as 20 and cos alpha as half, so it is I. Then we have V20 cos beta as 1 by root 2, that is j, and we have V as 20 and cos gamma as half, so that is k, and then we get 10I, then this is 10 root 2 j, and then this is 10k. So this is what we have, the rectangular form. So the rectangular form basically means that we are calculating the vector in 3D. So that is what our concept of rectangular form involves. Now this aspect of cos alpha, cos beta, cos gamma is very important, as we have a second relation which says that sine square alpha plus sine square beta plus sine square gamma. I hope you can understand, because here it comes 3 1 this comes 1 minus sine square alpha, 1 minus sine square beta, 1 minus sine square gamma equal to 1. So this becomes 2. So these two results, this one and this one, are very important for solving this kind of problems. Now the next one, as you can see, is an angle on, it's a problem on finding the angle between the vectors. Now determining the angle between the two vectors, we need to apply the dot product. Here it's very important that when it is given in the form of I, j and k, we need to calculate it with dot product, and when it is given in terms of magnitude, say 5 units, 12 units, find the angle between them, then we need to get through the parallelogram law. So that should be very clear. Now we know that for dot product it is a dot b, which is ab cos theta. Now this cos theta term is, as you know, due to the component of one vector on another. And then cos theta comes to the dot product of a and b divided by their mod values of a and b. So if you put the dot product here, we write it as 2i minus 3j plus 6k dot 6i plus 3j minus 2k, and then the mod value of root over of 2 square plus 3 square plus 6 square into 6 square plus 3 square plus 2 square. So that gives us minus 9 by 49. So this is a calculation part that you have to do. This is 2 into 6 12 minus 3 into 3 9, and then again minus 6 into 2 12. So that comes to minus 9 by 49. Now these two are same, so you put the mod value and get it 49. Now the angle between the two vectors theta is cos inverse of this, so that is cos inverse of minus 9 by 49. Now you should put the minus sign here within the bracket. Now the next part is the unit vector perpendicular to both a and b. So when you have anything perpendicular, you may have to you mean to know that if I have a vector a and b perpendicular, then it should be the cross product, which is c, that is a cross b. So here we need to get the cross product. So whenever you have to find a unit vector perpendicular to this, we need to get the cross product. So now in order to get the cross product, you know, when we are multiplying a and b, then we should put it like this, that a cross b, that is ab sin theta. And when you are doing the actual operation of a cross b, then you are putting this I, j, k, and then writing down the, this is the box where I should put the formula. And when you write down this coefficient, so that it's 2 minus 3 6, and then 6 3 minus 2. So this on calculation yields you minus 12i plus 40j plus 24k. Now mind you, you are asked to find a unit vector of this vector. So the unit vector, as you know, is the cross product divided by their mod value. So the unit vector that you are asking for is minus 12i plus 40j plus 24k divided by the mod value of this whole thing, which is root over of 12 square plus 40 square plus 24 square. So that is your unit vector. Now you can just simplify it, and at the end it will come as minus 3i, then plus 10j, and again plus 6k divided by root over of 145. So that is your result. It will come where there is unit vector perpendicular to both a and b. So these are methods which you need to understand very well. And the next problem you can see that we are talking about the projection of a on b. Now you see the taking projection, you have to understand that if this is a and this is b, then when you are taking the projection of a on b, then you are referring to this actually. So the projection of a on b is nothing but a cos theta. So as we have just learned that a dot b is equal to ab cos theta, so the portion of a cos theta should be equal to a dot b divided by the mod value of b. So that can be put in as vector a into the unit vector of b. So there are many formats in which this can be expressed. So you should know that this is again a very important format. So here we have to calculate a cos theta and then a dot b. So it is 2i plus 3j minus k dot minus I plus 3j plus 4k and divided by the mod value of b. So that is root over of 1 square plus 3 square plus 4 square. Now if you calculate this, then the dot product of ab, you see 2 minus 2 plus 6 minus 4, so that will give you 3, and this will give you the magnitude of b will give you root over of 26. So that is the value here, 3 by root over of 26. So that is the correct option. So this is a very important application again of projection. Now if say for example we were asked to find the other one, that is the projection of b on a, then you can understand very well then the projection of b on a is nothing but b cos theta. So in that case it will be b cos theta, which is a dot b divided by the mod value of a. So that is b into the unit vector of a. So that is this. Now I just request you to remember this form, because there are many cases where you are asked to say that which is the correct vector form of projection of a vector on another. Now we go on to the next one. So let us come on to the next one, which again is a problem on vector. You see the vector is given here that there are two vectors a and b. Sum a minus b is perpendicular to the difference of a minus b. So you see the ratio of the magnitude that you have to calculate. Now this is an operation on a particular property of dot. We'll come to that property, but before, what we need to say to you is that the sum of a plus b is perpendicular to a minus b. Now I must say that this is a plus. So you see a plus b is perpendicular to a minus b. Thus we know that when these two vectors are perpendicular, then their dot product is 0. So what we do is we put as a plus b dot a minus b, that should be equal to 0. So that gives us a square plus b dot a minus a dot b minus b square equal to 0. Now comes a very important property of the dot product, which we say that the commutative property, that is a dot b is equal to b dot a. So if that is the thing, that a dot b is equal to b dot a, then we can say from here these two just cancel out, and it comes that a square is equal to b square, or a is equal to b. So the magnitude of a by b is equal to 1, as they are same. So the magnitude of a and b happens to become 1. But this is a very important aspect which you need to understand, that whenever two vectors are mutually perpendicular, then their dot product is 0. There are many applications based on this, which is very important. So now we go on to the next problem. Now here we have a problem on relative velocity. You see, there are two cars, say A and B. They are moving in same direction, and they are having same velocity, both of them as 30 km per hour. And then they are approached by a second car C, and now you see they meet these two cars at an interval of 4 minutes. So these two cars are moving actually not side by side, but they are moving like this. Say A and B, they are moving like this, and they have separated by this. They also have a separation which is 5 km. Now the relative velocity between these two cars is 0. That is what we mean, as they are moving in the same direction. But as this car is approaching from the opposite direction, the relative velocity should be v minus of minus 30. That is the relative velocity. So that is v plus 30. Now we apply the time as distance by relative velocity, and the distance is 5 km. The relative velocity is 5 plus 30, and the time here is 4 minutes. So that is 4 minutes means it's 4 by 60. So in terms of hours, so that is 5 v plus 30. Now if I solve this, then the value of v will come to 45 km per hour. So the velocity of this car should be 45 km per hour. So I hope it is clear to you all that initially the cars are moving with same velocity but having a separation of 5 km, and when this car approaches them from the opposite direction, it has a relative velocity of v plus 30, and it crosses 5 km within a time interval of 4 minutes. So that is how we solve it out. Now this problem, the next one, as you can see, is a very important one, as it is based on crossing over of river. Now crossing over of river problems, as we know, there are two cases involved here. One is the shortest path and the other is the shortest time. Now for the shortest path, you see, the man who has to swim has to reach the opposite point of the opposite bank. Now this is a criteria that the man should reach the opposite point of the opposite bank, and now the velocity of the current, that is the velocity of river, is 2, and the velocity of man in still water is 4, and this resultant velocity the man is going to reach here, the resultant velocity Rs, is what we are going to calculate, but that's later. First we need to calculate this angle at which the man should swim so that he can reach the opposite point of the opposite bank. Now as these two values are given, we see it is basically the base and the hypotenuse, so we relate it with sine theta. So sine theta is 2 by 4, so that is half, so it is sine 30. So the angle at he should swim is 30 degree. So in what direction he should be headed? He should be heading at an angle of actually 90 plus 30, 120 degree with the river flow, 120 degree with river flow. So that is what he should head for. So that is the first part of the problem. Now if the width of the river is 4 kilometers, so if the width of the river is 4 kilometers, then you see this his velocity is given as 4. So here you have to take a component of the velocity along this, that is 4 cos theta, and the time in which he should cross the river should be given by 4 divided by 4 cos 30. So this is the resultant velocity along which the man is moving, and if he has to cross the river, then this is the time. So it is very clear that 1 by root 3 by 2, so that is 2 by root 3. Now this is hour, I tell you. Now for shortest time, you see in what direction he should head if he is to reach the river in shortest time. Now for shortest time, the situation is this, that he should be heading along the minimum path. So that is why he is deviating away here. This is his resultant velocity, and so you can see that when the man is trying to cross over the river in shortest time, then his the time he takes to cross the river is simply 4 by 4, because theta is 0 here, so it is 1 hour. So that is the time, the shortest time that he is taking to cross the river. Now the fourth one, that how long will it take to row 2 kilometers up the stream and then back to the starting point, is that if he starts and swims in 2 kilometers up and down, then when going up and down he has to travel a total time which should be equal to 2, 4 minus 2, and then 2, 4 plus 2, because when it is traveling up he is adding the velocity, and when he is traveling down the velocity gets deducted. So that gives you 1 plus 1 by 3, so that is 4 by 3. So 4 by 3 hour is the answer for the fourth one. So the first part of the answer is 120 degree with the river flow. The second is the time, that is 2 by root 3. The third case is a time of 1 hour for shortest time, and then the final case we have a time of 4 by 3 hour. Now the next problem is a problem based on rain and man. Now here we have a man who is walking at a velocity of 3 km per hour, and the rain appears to fall vertically. When he increases to his speed to 6 km, it appears to fall at an angle of 45 degree with the vertical. Then what is the velocity of the rain? Now see, in the first case, the velocity of the man, if we consider the velocity of the man in the first case, then it is 3I. And the velocity of the rain with respect to the man, if we consider it, then it comes to the velocity of rain with respect to man, it comes to a minus 3I plus bj. So why is a minus 3? Because previously let the velocity of the rain is ai plus bj, and then the speed of the rain is root over a square plus b square, and then the velocity of the man is 3I, and the velocity of rain with respect to man is vr minus vm. So vr is now a minus 3 plus b. Now as it seems to fall in a vertical position, so as the rain falls vertically, then we can conclude that a minus 3 should be equal to 0. As a minus 3 is equal to 0, a becomes equal to 3. Now in the second case, the velocity of the man is 6I. Now in this case, the velocity of rain with respect to the man is a minus 6I plus bj. So that is, a is already we know 3, and 3 minus 6 is minus 3I plus bj. And now this seems to be 45 degree with the vertical. So we can say that the mod, this, as it seems to be 45 degree with the vertical, then tan 45, that is 1, that should be equal to b by 3. So that makes b as 3. So the equation of the rain, now as we know, the velocity of the rain should be equal to a square plus b square. So a we have calculated as 3, and b we have calculated as 3 as well. So that gives us the value of 3 root 2 km per hour. So we just repeat once more. The first case, that a man is walking at a velocity of 3 and the rain is falling vertically. So the man has a velocity of a and the rain has a velocity of b. In the first case, the velocity of the man is 3, so it is 3I, and the velocity of the rain with respect to the man is a minus 3 plus bj. Now as the rain falls vertically, we have a minus 3 equal to 0, so a is equal to 3. And in the second case, it is a minus 6I plus bj, where a is the velocity of the rain along I-axis and b is that along j-axis. So the velocity of the rain as with respect to the man, here it comes to a minus 3 and here it comes to a minus 6. So this is very important aspect, and this problem itself is a very important problem on Rain Man situation. Now we come to a problem which is based on error analysis and its limits. So here we have to calculate the area of a particular block, of a lamina rather, with the limits of its error. Now for this calculation, what we actually do is we actually add the values and then calculate within the error limits. So if we calculate the area, then it should be simply the addition of the two sides. So if we are adding the two sides in this case, then we have that the length and breadth of the rectangular lamina. So the length, as we can see, is 2.3 plus minus 0.2, and the breadth, as we can see, is 1.6 plus minus 0.1. So I have to actually multiply these two. So when I multiply the mod values, L into B, then I have it as 2 into 3 into 1.6. So that is 3.68 centimeter square. Now what we have is, as I apply this, the log on both sides and all that, taking log on both sides and differentiating, then we have del A by A, that is equal to del L by L plus del L by B. So here is a lot of calculation involved. So del L means the change that I have in length, that is 0.2, by the original length, that is 2.3, and then del B is this 0.1 by the original length, that is 1.6. So this on calculation will give you 0.55 divided by 3.68. Now if we calculate the delta A, that is the change in area, that is 0.55 divided by 3.68 into A. Now A we have already calculated as 3.68. So we can see that 0.55 into 3.68 divided by 3.68. So that is again 0.55. So we can write the area now as 3.68 plus minus 0.55 centimeter square. So this is how we deal with errors and analysis. And then we come to the next problem on this error analysis. Here the percentage is given. So if you take the log on both sides and write the whole thing, then we get del x by x into 100, the percentage error in x, that is 2 del A by A into 100% plus 3 del B by B into 100% plus del C by C into 100%. Mind you, we need not minus this because everything is added in error analysis. Then it is half del D by D into 100%. Now all these values are given here. So it is 2 into 2 plus 3 into 1 plus 3 plus half into 4. So that is 4 plus 3 plus 3 plus 2. So that is 12. So 12% is the error in calculation of x. Now you can do it just mentally by multiplying the powers involved. So the power of A is 2, power of B is 3, power of C is 1, and power of D is half. So you multiply this by the given percentages, that is 2, that is 1, that is 3 and 4, and you can mentally calculate the answer as 12. So this you can do if you want to do the problem very quickly without writing and all these things. Now we have a problem on measurement, that is a vernier caliper. Now we know that the LC is what we have, the least count of a vernier caliper is what is very important. It is 1 MSD minus 1 VSD. So that is the main scale division and the vernier scale division. So here it is given that 20 divisions of vernier scale, so 20 VSD, that is equal to 16 MSD. So we have 1 VSD is equal to 16 by 20 MSD, and then that calculation is 0.88 millimeter. So now the value of least count, as you can see, is 1 MSD minus 1 VSD. So the 1 MSD is 1 millimeter, so it is 1 minus 0.8, so the least count is 0.2 millimeter. Now we have another problem here. The problem is a force applied on a square plate of side L. If the percentage error in determining L and that of F is 4, then determining the pressure. Now you see, the thing is that pressure, as you know, is force by area, and area here can be crudely written as L square. So if we do taking log on both sides and making the case of percentage error, then the calculation goes on like this as we are putting it here, or you can even do it mentally as we have just learned a few pages ago. So now you substitute the errors. You see, the determining L is 2 and force is 4. So force is 4, that means this whole thing is 4, and the whole in length is 2, so it is 4 plus 4, that is 8%. So the error in calculating the pressure is 8%. Now again we have a problem here, that is a magnitude and of sum of two vectors is equal to the magnitude of difference of two vectors. Now as you can see, the magnitude of sum and magnitude of difference, if we make them, then it happens to become 90 degree, because you see what you have to do is basically write a square plus b square plus 2ab cos theta, that is equal to a square plus b square minus 2ab cos theta. So that makes you 4ab cos theta is equal to 0. So, and write that cos theta is 0, which is equal to cos 90, and that makes theta as 90 degree. So it's the fourth option which is correct here, that it is 90 degree. So we begin our mathematical problems discussion on kinematics, and the first problem that you see is an equation of displacement, which is a plus bt square. Now we know that velocity is differentiation of displacement, so it is dx dt, so that is 2 bt on differentiation. So the velocity at when a is 15 and b is 3 centimeter, and instantaneous velocity at time t second will be 2 into 15 into the time 3. So it is, now you have to be careful, b is 3, so it is 2 into 3 into 3, so that is 18 centimeter per second. So that is the velocity here. Now the next problem is also based on velocity, but this time we have to do something more. Now the equation is given as 3t, that is equal to root over of 3x plus 6. So what we can write here is root over of 3x, that is equal to 3t minus 6. So we can write it as 3x is equal to 3t minus 6 whole square. Now we can write this as x equal to 3t square minus 12t plus 12. So if you calculate the velocity, that is dx of dt, so we have to differentiate this 3t square minus 12t plus 12. So that will give you 6t minus 12. Now if the velocity is 0, then 0 is equal to 6t minus 12. So t is equal to 2 seconds. And then at t is equal to 2, and then at t is equal to x is equal to 3 into 2 square minus 12 into 2, then plus 12. So that happens to become again 0. So the displacement is after that time is 0. So when velocity is 0, the displacement is also 0. Now here we have a problem which is basically based on average speed and Along with that, the concept of distance and displacement. So in this case, when the particle is moving along a path which is circular, what we have is that the total distance by total time. So you see a circular particle started from A, and this is the radius, which is 2 meter, and the particle starts from A and comes back to A again. So the average speed here is the total distance divided by the total time. So now the total distance, as you can see, is the circumference, which is 2 pi into 2, and the total time is given as 2. So it is 2 pi meter per second. So that is the time taken by the particle to make the whole path move in a whole circular path. Now if a particle has moved half the path, then you would have considered it pi r, that is pi into 2. In that case, the answer would be only just pi. So you kind of to understand this thing. Now here we have a problem where we have a car moving in a particular path, and then the maximum velocity reached and the total distance traveled. We have to calculate. Now here you see the first part is that the Vmax, as you can see very clearly here, Vmax, where the rate of acceleration is alpha. So we know that Vmax, that is the velocity max, is alpha t1, and again from this particular value of t2, we have Vmax is beta t2. So the total time taken, that is t1 plus t2, will be Vmax by alpha plus Vmax by beta. Now it is Vmax 1 by alpha plus 1 by beta, and then we can find out that if you just break it like this, that Vmax is alpha plus beta divided by alpha beta, then we can say that Vmax is alpha beta alpha plus beta into time t, and then the distance traveled in time t is the area under the graph, which we can also calculate as distance is half into Vmax, that is the height, and the total time t. So as we have already calculated Vmax as alpha beta alpha plus beta, that is t square. So this is the distance which has been traveled here by the particle, because the velocity time graph, the area gives us distance. So that is how we calculate these problems. Now we have a problem which is basically based on application of you see kinematical equation. So as the acceleration is constant, we can write that the distance is half at square, since because u is equal to 0 here. So in the first case x, we can write that x is equal to half at square, and then in the next second, that is y, the total distance travel in 2 seconds will be x plus y, that is the distance, is half a into 2t whole square. So that will be x plus y is equal to 2at square. So that is your second equation here. Now from 1 and 2, what we can do is, you can write that x plus y is equal to 2 into 2x. So that makes you 4x. X plus y equal to 4x. So y is equal to 3x. So this is the distance that the particle can travel in the next time t seconds. So in that case, that is a relation between x and y. Now this problem of a passenger away from a bus, and the bus begins to move, and the passenger runs at a constant speed. What is the minimum time he may catch the bus? Now this problem can be solved here by the process as we just learned here, that the bus, let this be the bus which is standing here, and here is a man who is standing at a separation of d, say for example, and the bus is accelerating with a, where the man is moving with a constant velocity v. Now for the passenger to catch the bus after time t, the distance travelled by the passenger is given by s1, which is half at square, and the distance travelled by the, now this is the distance travelled by the bus, and the distance travelled by the passenger is u2. Now the passenger will catch the bus if d plus s1 is equal to s2. So it is d plus half at square, that is equal to ut. Now if I make a quadratic equation from here, which is at square minus 2ut plus 2d equal to 0, and then I apply the Sridharacharya to find t, then we have 2u plus minus root over 4u square minus 4a into 2d divided by 2a. So that will give you u plus minus root over u square minus 2ad by a. Now it is very logical that the passenger will catch the bus if t is real. So in that case u square, the discriminant, should be greater than equal to 2ad. So in that case u should be greater than equal to root over of 2ad. So that is a condition which the man may catch the bus. So this particular case is very important for other problems also, like chasing a thief and catching him by the police and all that. Now we come to the next problem here. The next problem is a graph. So we have to choose a correct graph. Now the distance time graph is given. So you can see that distance is path length, and distance, whatever you say, is a quantity which is a scalar and which also always increases with time. So this graph cannot be true, because you cannot have two positions in a single time, and in this case the same thing, that distance cannot be negative, and again distance cannot be negative. So this is the only graph which can be correct, where distance is getting up positive more and more. So this is a correct graph which we have here. Now we come to the next problem, where there is a VT graph given and the motion is along the straight line axis. We have to find the duration of the displacement 3 seconds, and then we have to find the distance covered in the duration of 4 seconds. Now for velocity, what we know is that the displacement of the area under the VT graph, that we can calculate. So it is for the first case, it is half into 2 into 2, which is the area of this case, and then we have to find this, because for 3 seconds we are calculating. So mind you, for this, so that is minus of half into 1 into 2, because the base here is 1 but the height here is 2 itself. So that on calculation is 2 minus 1, so it is 1 meter. Now we need to calculate the distance. Now that is the difference, that when you are calculating the distance has only the mod value. So in that case we need to calculate this area, the area under this curve as well as the area under this curve. So for that we have half 2 into 2 plus again half 2 into 2. Since you are calculating the distance here, and this was displacement, mind you, since you are calculating the distance here, we need to take only the mod value. So it is 2 plus 2, that is 4 meter. So this is a very thin difference you have between displacement and distance from graphical area. Now we go on to the next problem. So here we have a problem on vertical motion, where we find a ball which is going upward and finally returns to the man after 8 seconds. So you have to find the time after the time speed with which was thrown up, and we should consider g as 10. So the displacement, as you can see, is the ball, as the ball goes up and comes back to the same point as the ball goes up and comes to the same point, the displacement is 0, so that is ut minus half gt square. So from here you get the velocity u, which is half gt. Now half gt is half into 10 into 8, so that is 40. So it was projected with a velocity of 40 meter per second. Now the maximum height, as you know, it is u square by 2g. So it is 40 into 40, 2 into 10. So that is 80 meter. So the ball has been going up to a distance of 80 meter. And the position after 6 seconds is s is equal to ut minus half gt square. So the initial velocity we have 40 into 6 minus half into 10 into 6 square. So that will give you a value of 60 meter. So this is how we solve the problem on this, because the first case we have to consider the displacement as 0 as the ball goes up and comes back to the point from where it has been thrown. Now we come to the next problem, where we have a juggler throwing balls into air, and he throws one whenever the previous one is the highest point. So how the ball rise if he throws n balls in each second? So this is very important, that at what interval he is throwing the balls. So at the highest point we have u equal to 0, and the time at which he is throwing the ball is 1 by n. So we have, if we apply that v is equal to u minus gt, then we have 0, that is equal to u minus g into 1 by n. So here we have u as g by n. So this is our first equation. Now again we have v square equal to u square minus 2gh. So again 0 is equal to u square minus 2gh. So h is u square by 2g. So u is g by n, so it is g by n square by 2g. So that will give you g by 2n square. So for any value of n, you can substitute the value here, and the correct option will be the second one. So it is g by n square. So with that we come to the end of our discussion with kinematics.